Everyone, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about one form of mechanical energy, that is kinetic energy. Today we are going to discuss about the second type of mechanical energy, which is known as potential energy. So we had already discussed in our previous session, mechanical energy is mainly of two types. One is kinetic energy and the other form is potential energy. And kinetic energy is the energy possessed by an object by virtue of its motion. So what will be potential energy? Let's discuss about potential energy today. So before discussing about potential energy, consider some examples. Just take a rubber band and stretch it. Okay, when you remove the stretching force, rubber band goes back to its original size. So while stretching, if you keep your arm there, you will feel pain, isn't it? So what is happening here? Why do you feel pain on your arm when the rubber band is stretched and released? So this may be due to the energy acquired by the rubber band during stretching. So in order to stretch the rubber band, we have done some work, and that work done is transferred in the form of energy, or that work done is stored in the form of energy inside that rubber band. So this energy stored can be considered as the potential energy. Okay. Now similar example you can consider, that is, take a toy car, wind it using its key, place the car on the ground. What happens? Does it move? Yes, it will move. So from where did the car acquire energy to move? When the key is wound, the car gets energy to move. So what happens? We have done some work to wind the key. That work done is stored inside that spring of the key as potential energy. So in the above situations, the energy gets stored inside the object due to the work done on the object. Whenever some work is done on the object, some energy gets stored in that object. Okay, and this energy transferred to an object is stored as potential energy. It is not used if it is not used to cause a change in the velocity or speed of the object. Okay, so if we have done some work on the object, and if that work is utilized to change the speed of that object, then that energy can be considered as kinetic energy. But if that energy is stored in it, if that energy is simply stored in the object, then that energy can be considered as the potential energy. Similarly, if we raise a stone from ground to second floor of a building, the stone is able to do some work now, isn't it? When the stone is simply there on the ground, it is not capable to do any work. But when the same stone is raised from the ground to a certain height above the ground, it is able to do some work. Okay, and this work done, or the energy responsible for this work, is potential energy. Okay, so the potential energy can be the energy possessed by an object due to its position or due to its configuration. Right, so let's discuss potential energy. Energy possessed by an object by virtue of its position or configuration is called as potential energy. Potential energy is a relative term. You can choose reference position where it is 0. And you will understand more about this concept in our coming sessions. And here on this figure you can see a person is stretching the bow and releasing an arrow, isn't it? So when the arrow is released by stretching the spring, or not spring, actually it is a string. So when the string is stretched, arrow is released. Okay, the arrow will fly off the bow. So here what happened? When the string is stretched, there is a change in the shape of that string. Shape means configuration of that string. And when the arrow is released, what happens? the work done in stretching the string is stored as potential energy inside the string, and when the arrow flies off the bow, what happened? That potential energy is converted into kinetic energy of the arrow. Okay, so three energy conversions are taking place here. When the string is stretched, some work is done. That work done is stored in the form of potential energy inside the string, and when the arrow is released, the potential energy of the string is converted to kinetic energy of the arrow. Okay, so energy possessed by an object by virtue of its position or configuration, configuration means shape, is called a potential energy. Okay, so you transfer energy when you stretch a rubber band. The energy transferred to the band is its potential energy. You do work while winding the key of a toy car. The energy transferred to the spring inside is stored as potential energy. So the potential energy possessed by the object is the energy present in it by virtue of its position or configuration. Now, an object's energy increases when it is raised through a height. This is because work is done on it against gravity while it is being raised, isn't it? So I had told you similar example before. When the stone is raised from the ground to the second floor of a building, it possesses some energy. Similarly, when the stone is again raised from the second floor to the fourth floor of a building, the capability to do work, that is its energy, again increases. So an object's energy increases when it is raised through a height because work is done on the object against gravity when it is being raised. And energy present in such an object is the gravitational potential energy. Okay, so when the object is situated at a certain height from the ground, then the object possesses potential energy, and that potential energy is known as gravitational potential energy. So the gravitational potential energy of an object at a point above the ground is defined as work done in raising it from the ground to that point against gravity. Okay, so consider this example. This is the ground and a stone or a ball is lying here. This is the second floor of the building. This is the third floor, fourth floor, like that. Okay, so when the stone is raised to the third floor of a building through a height h, it possesses some potential energy, and that potential energy is the gravitational potential energy. So what work is done to raise this ball or object from ground to this point? That will be the potential energy of that object at this point. Okay, so this is gravitational potential energy. And how can we arrive at an expression for this gravitational potential energy? So we know that work done is force into displacement, right? And this work done itself is stored in the form of potential energy. Okay, gravitational potential energy also. So in this case, what will be force? Since here gravity is influencing the object, force can be considered as the gravitational force mg. And what is the distance? How much distance or how much the object has been displaced from the ground? So this is the distance or displacement, height, h, isn't it? So here the displacement is h. So the work done W is mgh, mg into h, that is mgh, and this itself will be the expression for gravitational potential energy, where m is the mass of that object, g is the acceleration due to gravity, and h is the height through which the object has been displaced from the ground. Okay, so the expression for gravitational potential energy, EP means potential energy itself, is mgh. Okay, now see, whatever I had discussed just before is again written in this slide. Gravitational potential energy is mgh, where m is the mass in kilogram, g is acceleration due to gravity, that is 9.8 meter per second square, and h is the height above ground expressed in meter. Now, this work done by the gravity depends only on the vertical height difference of initial and final positions. Okay, so that means the work done in raising an object from one point to another point depends only on the height difference between the initial and final position. It is not affected by the path chosen to raise the object from initial point to the final point. Okay, so in the figure you can see the object has been raised from the point E equal to 0 to E equal to mgh through two different paths. One path is a straight path represented by this line, and another part is a curved path represented by this blue curved line. So in both the cases, whatever be the path chosen, in both the cases, the work done by the gravity will be same, because the initial position and the final position in both the cases are same, isn't it? For this path, for this vertical path, initial position is E equal to 0 and final position is M equal to mgh, because the object has been raised from E equal to 0 to E equal to mgh. And for the second path, which is the curved path represented by this blue curve, initial point is E equal to 0 and final point is E equal to mgh. So initial and final positions are same. So work done by the gravity also will be same. Okay, so in both the cases shown, work done is same. Thus the potential energy is also same, that is mgh. So the potential energy does not depend upon the path. Okay, so that's all about potential energy. With this I am concluding the session. Also, notes of the topic and YouTube video are uploaded. Just go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.